Right. So you're going to try this one for me. What volume, where's my pen? What volume at RTP? What volume at RTP? Sorry, what is the volume at RTP of 0.3 moles chlorine gas? What is the volume at RTP for 0.3 moles of chlorine gas? Work that out quickly. That answer 7 point. So look what's happening now. Let's start with what we know. We know that 1 mole of any gas occupies 24 dm cube because now we are at RTP, not STP anymore, RTP. All right, so that is where we are at, not STP, RTP. Now, the gas that was given to us is chlorine. What we're trying to do is to find out what would be 0.3 moles. How much will 0.3 moles occupy? So simply put, it's 0.3 times 24, and you get 7.2 dm cube. Let me give you one more. Let me give you another one. All right, what is the volume at RTP? What is the volume at RTP for 2.5 moles of sulfur dioxide? Volume at RTP for 2.5 moles of sulfur dioxide. Try that one. Down to 2.5 times 24, and what do you get as your answer? Flip the script, right? And we're going to look at number 2. So number 2, which is down here, says calculate the number of moles. Calculate the number of moles in 2.4 dm cube of oxygen gas. Calculate the number of moles in 2.4 dm cube oxygen gas. And the condition is RTP. So we're at number 2. Condition is RTP. So let's go again. You're going to start off with what you know. 1 mole of any gas occupies 24 dm cube at RTP. That's what we know. What they want to know is how many moles would there be if I had only 2.4 dm cube of the gas. That's what they're asking, you know. So again, you can do it the math way, ladies, by doing your cross multiplication. Nothing is wrong with that. Absolutely nothing is wrong with it. Or you can reason it out. I have 2.4 out of 24 dm cube. What's my moles? And you work it out. 0.1 moles. So this one is quite easy. Find out the number of moles. Hold on now. My formula persons. I want you to deduce number of moles. Find a formula for me. Find number of moles from volume, molar volume. Let me write it better and not use the sign. Find number of moles from molar volume. I want a formula that was given, or the given volume over the volume at either RTP or STP. See, you can actually deduce these things, you know. So you don't have to be relying on a textbook, ladies, or some other source to tell you that this is a formula for it. If we reason it out, once we get to our last line, we can actually come up with the formula for ourselves. So this one we can even call it N is equal to V over Vm, volume over molar volume. And of course, the molar volume is either at STP or RTP. We can figure out these things for ourselves, you know, and you write them down. Now we're going to kick it up a notch, because you know we can't make it stay like that. Too simple, man. Your brain's going to get lazy on me, and I can't afford that. We are now going to fuse. All right? Let me give you the example before I show you. Listen to this question before I show you the example. How would you solve this, lady? So I don't need an answer. I just need for you to tell me, how would you approach this? The question is, ready? What is the mass of 48 dm cubes of oxygen at RTP? What is the mass? Let me see if I can scribble it. I don't want to scroll too far and show you what we're talking about, you know. So what is the mass of 48 dm cube of oxygen gas at RTP? How would you solve that one? Think about it. 1 minute. Number of moles and volume of gas. Good. So your molar volume shows you the number of moles, the relationship between moles and gas. What did they introduce right here? Introduce mass. All right. So is there something that I know, right? But that's what we need to do, because remember, the volume gives us the relationship between the moles and the volume of the gas occupied. See it there? So we need to find the number of moles. How are we going to find the number of moles given the mass? Mole occupies 24 dm cube because it is RTP. And so we need to find out what mole occupies 48 dm cube. Now they're asking what's the mass that occupies. So if I have 2 moles of the oxygen gas, what would be the mass of 2 moles? All right, so hold on now. Remember that oxygen has an RAM of 16. But what do we have? Oxygen or oxygen gas? So what would be, this would be 32. Good. So if I have 2 moles of this, right? I'm just pointing this out here, ladies, but it really, if I have 2 moles of this, what would be the mass of oxygen gas? 64 grams. Right, ladies. So I'm going to show you another relationship that we can use. So let's look at their example. Example number 1. It says, calculate the volume occupied by 6.4 grams of oxygen at STP. Now, in their example, they showed you calculating the mass of 1 mole, which is 32, which is what we did, right? And calculating the number of moles, which is what we did up here. Then, from the number of moles, we found the volume occupied, which is what we did. All right? We're going to, again, kick it up a notch. Let's look at a different way, another relationship that we could form. All right? So, you're looking at mass and volume occupied, molar volume. We want to form a direct relationship between mass and molar volume, right? So we kind of want to cut out that extra step of trying to find the moles. Then from that answer, we move on to finding the volume. So again, there's nothing wrong with doing that, ladies. If that your preference, is your preference. But let me show you another way. All right? Let's write down two things that we know. Certainly know, because we're looking at volume. We know that 1 mole, I remember we're looking at this question here, please. This is a question that we're looking at. So what do we know? We know that 1 mole of oxygen occupies a volume of 22.4 dm cube at STP. We know that. We also know that 1 mole of oxygen has a mass. Remember, these things are matter. Matter is anything that has mass, dot, dot, dot. So 1 mole of oxygen gas must have a mass, ladies. And we know that it is 32 grams. That's what we know. Now, what we're trying to do is to form a relationship between these two. Now, if 1 mole of oxygen has a mass, I can say that 32 grams of oxygen will occupy 22.4 dm cube. Look at it and tell me if you see where I'm going. I know 1 mole occupies and I know 1 mole has a mass. And so I can form the relationship by saying 32 grams of oxygen, the 1 mole, occupies a volume of 22.4 dm cube. 1 mole of the gas, the molar volume. 32 grams of oxygen, which is equivalent to 1 mole, ladies. So instead of me saying 1 mole of oxygen occupies 22.4 dm cube, I know the mass, and so I'm going to substitute, ladies, 1 mole. That's what I'm doing, you know. I'm substituting the word 1 mole of oxygen with the grams that is associated with. So I get 32 grams of oxygen occupies 22.4 dm cube. And then I'm going to continue. What would 6.4 grams of oxygen occupy? That's what they're asking. Right? And of course, you can do math and cross multiply, but it boils down to you saying, listen, I have 6.4 grams out of my 32, which is my total. How much is that going to occupy? So I multiply that by my 22.4 and then I calculate. You calculate it, you should get that 4.48 dm cube. So there are so many ways you could approach this, ladies, right? That are sequential and they are logical. So we can do it step by step, writing the relationship, finding the moles. From the moles, I will find the volume. But then we can form a direct relationship between the mass and the volume.